Hello class, and welcome to our video lesson on electricity. In this particular video lesson, we're going to explore some different concepts of electricity. We'll talk a lot about circuits and what's happening within those circuits. We'll also discuss the two different types of circuit in this video as well. Let's go ahead and look at our first term. First of all, let's talk about the basic definition of what electricity is. Electricity is produced by the movement and distribution of charged particles known as electrons. Remember, electrons are the parts of the atom, and the electrons are found on the outer parts of the atom outside the nucleus. It's because of these electrons that atoms are able to combine and join with other atoms in different ways. Well, the ability of these electrons to jump from atom to atom is what easily results in what we refer to as electricity. Current. What is electric current? Well, whenever you have the flow of electric charges along a path, that is what we would call current. Current is typically going to flow from an area of high energy to an area of low energy. And if you're looking at this simple path that you have here, of course your battery is where your current is going to originate. And if you've ever looked at a battery, you probably have noticed that it has a negative and a positive end. These are what we call the terminals. And at the negative end is where you're going to have a higher concentration, I guess you could say, of electrons, of negative charge. So those electrons, of course, is going to always repel each other. So they're trying to figure out a way to get away from so much negative charge. So that is what results in the negative flow of electric charge going from the negative terminal around to the positive terminal where there's not as much negative charge here. But that is what you call current. It's just the flow of electric charges along a path. Voltage. Now, how much force this electric current is flowing along that path is what we would call voltage. The energy that a power source gives electrons in a circuit is what we refer to as the voltage. As the voltage increases, then there's more energy available to be transformed into other forms of energy. And we've all looked at batteries and seen the number and then the V symbol behind it. So this would stand for 1.5 volts. And that is the amount of energy that's being provided into the circuit. With how much force are those, is that current going to be pushed through that path? And that is what we refer to as voltage. So voltage and current are very important. Current is the flow of the charge, and then voltage is how much force is that current flowing, being pushed with through the circuit or through the path. All right, resistance. Let's talk about resistance next. The resistance in a circuit is the measure of how difficult it is for electrons to flow through a material, hence the word resist. When something is resisting something, it doesn't want to do something. Insulators are generally going to have a much higher resistance than conductors. As the resistance in a wire increases, the thermal energy will also increase because there's more friction. Whenever you increase the resistance, you've got things kind of pressing against each other more, so you're going to, of course, produce more thermal energy. Copper, for example, has a low resistance and is used in household wiring because it usually does not become hot enough to cause fires. So that's why copper is a common wire that's used in our household wiring because of the low resistance that it has, and you don't have to worry about too much thermal energy being produced, which of course could cause fires. Resistance will also depend on the length and thickness of the wire. The resistance of a wire increases as the wire becomes longer or as it becomes narrower. All right, so let's kind of review those three terms that we just went over because they're all represented here in this picture, okay? The electric current will be represented here by these negative symbols within this little yellow circle. That's just your charges flowing through the circuit. The voltage is the amount of energy that's given to those electrons. How much force are those electrons being pushed with through this circuit? That is what you refer to as the voltage. And then the resistance, which is kind of represented with this hand here, is the how difficult is it for these electrons to flow through a material? Is there low resistance or is there high resistance? And like we mentioned here, there are some things that can affect resistance, such as the length and thickness of the wire. If you have a thicker wire, you're not going to have much resistance versus if you have a thinner wire. It's going to be harder for those electrons to get through. Okay, so that's kind of how all of those words work together. You've got voltage, current, and resistance. All right, now let's talk about circuit because we've kind of mentioned this word already in some previous slide, but let's get some specifics about what a circuit is. Well, a circuit is a closed path through which electricity can flow. Energy will flow only through a closed circuit. If you open up the circuit, then what you're doing is stopping the movement of those charged particles. Within the circuit, we have a load. A load is any device in a circuit that operates using the electrical energy. You can think of a load as anything that is using the energy that's being delivered in the circuit. So it could be something like a light bulb, a bell, a radio, a motor, a cell phone. Anything that you put in a circuit that's using that electrical energy is what we would call a load. A switch is another part of a circuit. A switch is actually a device that is used to control the flow of current through a circuit. So think of a switch as like an on-off button on objects. When you turn something on, you're allowing electrical energy to flow through it. You're closing the circuit. And then when you turn it off, you're opening the circuit and kind of stopping the flow of electrical energy through that circuit. So that's some different parts that make up a circuit. You've got a load, which is what's receiving the electrical energy in the circuit, and then you have a switch, which kind of controls the flow of the current through the circuit. There are two types of circuits, and we'll get into those now. The first circuit is a series circuit, and you probably remember learning about series circuits when you were in elementary school. A series circuit is a circuit that provides only one possible path for the flow of current. So let's talk about what that actually means. Whenever you have a series circuit, you have everything connected in one path, all right? So, well, what is the advantage and disadvantage of this? Well, let's look at that. The advantage of it is that you can add more power sources like batteries, and it will give you more energy in that circuit, more electric current and more voltage flowing through that circuit. However, the disadvantage of this is that if you have a failure or a break in any part of the circuit, it's going to stop the flow of current through the entire circuit. Sometimes you'll get Christmas tree lights that are wired in a series circuit, and if one bulb blows out, the whole entire string of lights will stop working, and you would have to end up replacing that broken bulb or trying to figure out which bulb is broken. But that is what we refer to as a series circuit. Everything is connected along one possible path. The other type of circuit is a parallel circuit. A parallel circuit is a circuit that provides more than one path for the flow of electricity. So now you can see here the difference in the pictures. We can see here that you've got more than one way for the current to flow along this circuit. And remember, whenever current is flowing through a circuit, it always starts from the high concentration area, the negative terminal, where you've got a higher concentration of electric charge, and it flows around to the positive terminal, which is where you have less electric charge. So if you can find more than one path for that to happen within a circuit, then you have a parallel circuit. The advantage of a parallel circuit, which was actually the disadvantage of a series circuit, is that if you have a failure or a break in one part of the circuit will not affect the flow of current in another part of the circuit. So that means current will continue to flow. The disadvantage, however, of parallel circuit is since you're trying to create all these different paths, you are going to require more conducting wire in order to create parallel circuits. All right, Ohm's law, okay? Now we've talked about voltage and current and resistance and kind of how all those words are related. Well, Ohm's law, which was created by a scientist with the name Ohm, he actually came up with a simple relationship between voltage, current, and resistance. Now, according to this law, when the voltage in a circuit increases, the current will also increase. However, if the voltage doesn't change, then the current in the circuit decreases when the resistance is increased. So this particular relationship is expressed in an equation, which we call Ohm's law, and it is it is shown here. And the equation is voltage equals current times resistance. Voltage, of course, we measure in volts with a V as our symbol. Current is measured in amps, and then resistance is measured in ohms. And the equation, this is what the basic equation looks like. It's V equals IR is how you would solve that. Let's look at an example of Ohm's law, okay? It says a light bulb is plugged into a wall outlet. If the light bulb has a resistance of 220 ohms and the current in the light bulb is 0.5 amps, what is the voltage provided by the outlet? So this is a simple one because all we've got to do is identify what we know. We know that the resistance is 220 ohms and the current is 0.5 amps. So our Ohm's law formula is V equals IR. So all we would have to do is plug these two numbers into the equation. 0.5 amps times 220 ohms We multiply those together and our voltage ends up being 110 volts. Okay, so Ohm's law is just simply a equation that just shows you the relationship between resistance, voltage, and current. Well, that concludes our video lesson on electricity. Please make sure that you have filled in all of your notes on your graphic organizer and go back and replay the video if needed.